So our question 2 was, so test statistic. Well, test statistic is going to be oh, 16, yes, sorry. So that's our test statistic. So we plug it things in, and that's 2.1 minus 1.2 divided by square root of, oh, sorry, divided by 1 divided by square root of 16. Divided by 1 divided by square root of 16. And that came out to be 3.6. Yes? Okay, so that's question 2. Question 10. Question 10 was find the p-value. So what we do is we say, hey, and our test statistics is going to be somewhere around here. Is this a left or right or two-tail test? This is a right tail test because of this. Right? So it's a right tail test. So we are looking for this probability, that's p-value. Now in our case, at 3.6, this part is going to be about that. So this part is going to be that. And that's our p-value. Now, this doesn't have a number that small, so you pick up the smallest number that there is, right? That's the downside of tests. I put the wrong number down. All right. So this is question 10. You just find the p-value. Question 18 is asking you, hey, if alpha is 0.01, what happens for alpha 0.01? I'm going to use the p-value method first. The p-value method says, hey, I'm going to compare the p-value versus alpha, the observed significance versus the significance level given to you. So what are we comparing? We are comparing 0.00001 to 0.01. Which one is bigger? Alpha is bigger, right? P-value is smaller, which implies that we're going to reject H sub 0. And we're done. That's one method. Method number 2. Method number 2 was the traditional method. That's the method I like. When I say, hey, I'm going to draw a picture. I'm going to say, hey, it's still a right tail test. So I'm still looking at this little section. How big is this section? Well, the section is still alpha. That's our significance level. So this is alpha. And I know that for this alpha and one-sided test, the critical value, the right side tail test with a significant value of 0.01, my dyslexia is killing me, gives us a critical value of 2.33. Right? Which means that our test statistics, which is 3.6, right, will end up being somewhere here. In the rejection, yes. In the friend zone. Right? And we reject H sub 0 because of that. Now, regardless if you use this one or this one, right, there's limitation to both, there's advantages to both. But this is how you do it. Did everybody get the same answers?